All right, welcome to the last lesson of week 2 of pre-calculus, and we're going to talk about solving inequalities. So your homework is from chapter 1, section 7. We have quite a variety of different problems. Again, I do not expect you to do all of these. Jump around, do maybe one in each of these clumps. Make sure you're challenging yourself, but not too much. The first thing we're going to talk about is how I want the answers written for inequalities and how the book will expect answers to be written as well. So make sure you get your notes ready to go and let's get started. We're going to talk about how to write the answers for inequalities using interval notation. So you might have been used to writing answers like this. 4 is less than or equal to x, which is less than 9, or negative 6 is less than x. This is how you're used to writing the answers, which is totally understandable. We're going to look at other ways to write the answers using what's called interval notation. And so that's a way to write the answer in just a much more concise way. It takes up less space. So when we talk about inequalities, we often talk about open and closed boundaries, which are demonstrated by these. So if you remember drawing them on a number line, the closed boundary is a filled in circle on the number line versus the open boundary, which is just an open circle. The closed goes with the symbols that are and equal to, whereas the open is the symbols without the boundary being included. And with interval notation, instead of writing out all these symbols and the variable, we're just going to use different brackets for closed, which means we're going to put the number there. So for example, here in A, it's a closed boundary. X is between 4 and 9, including 4. So we'd put a bracket, then 4, then you'll see a comma, and then the second number might also be in a closed bracket if the other one was closed. But here we can see that it's an open boundary, meaning that we're not including that final number. And for those, we use parentheses. You have to use some context clues to make sure that a completely open interval is not a ordered pair. Context will tell you exactly which one's which. So in the final boundary, it's 9. And that's going to be interval notation. These two things mean the same thing. They're just written in different ways, and this way is much more concise. It's just two numbers, and then your end symbols, whether it's a bracket or a parenthesis. Now here, the boundary, we only have one boundary for B. It's negative 6. And it says that negative 6 is less than x. So if you think about it on a number line, the solution would be an open boundary at negative 6, and then all numbers bigger than that. X is just anything bigger. So we have our lower boundary, our smaller number, which is open. It's negative 6. And that goes to infinity. And you can use infinity as your other boundary. And infinity is always going to have an open boundary. So whether it's positive infinity over here, or if it was less than, we'd use negative infinity. Infinity is always going to have an open boundary. Now here we have two different things. We have 4 is greater than x, and x is greater than 8. So again, sometimes with these, it's helpful to picture them on a number line. So here we have 4 is greater than x. So we've got an open boundary at 4, and x is less than that, since 4 is the bigger part, and x is greater than 8. So this is sometimes how the solutions of like absolute value problems, which we're going to see in a little bit, maybe will show up. So for this first one, x is less than 4. We would go to negative infinity, and then 4 is a open boundary. And on this side, we have 8 as an open boundary, and then to positive infinity. Again, you'll notice we're using infinity using the closed ones. But we want to show that it's both of these are possible. So this is for the first one, and. So we can write out the word and, as we've done here. There is also a symbol for the word and in intervals. And that symbol is a big U like this. And this is called the union. So it's saying that those ones together. And it stands for and. So instead of writing out the word and, you can just put this big U for union in between, and that is the final simplified answer for writing this in interval notation. So again, this is just another way to write it. It's another way to show the answers for these problems. It'll end up taking up less space generally, which is why textbooks really like it. So let's talk about solving these types of inequality problems, and we'll put our answers in interval notation at the end. So here is a reminder. We might have an interval like this. 4 is less than or equal to 2 minus 3x, which is less than or equal to 13. The way we'll start is just like we normally would. We'll subtract 2 so that this cancels out, but we're going to subtract 2 from the other sides as well. So remember, we've got sort of like 3 sections in these cases. So then we've got 2 is less than or equal to negative 3x, which is less than 11. Now, when we divide everything by negative 3, what you may recall is that that causes the inequality signs to flip. And the reason this happens is, you'll notice this is true of numbers as well. Here we have 2, positive 2, and we divide by negative 3. That becomes a negative number, so its sign flips. So why wouldn't the inequalities? So now this is a greater than sign from a less than sign. X is now by itself. Flips 11 over 3, negative from the negative 3 here. Now, here's what it would be in regular notation. We're more used to it flipped the other way, so that we're reading it with the signs pointed the other way. So you might see it written as negative 11 thirds is less than x is less than or equal to negative 2 thirds, sort of in the order on the number line. And that's how you're also going to write your interval problem. Your interval notation is, we always want to start with the smallest number, which is negative 11 thirds in this case, with an open boundary, to our larger number, which is negative 2 thirds, and a closed boundary based on our inequality signs. And so there's our final answer in scientific notation. Not scientific notation, interval notation, with your minimum and then your maximum, parentheses in between, deciding if you're using a bracket or parentheses. Now, here we have a lovely absolute value problem. Now, absolute value problems have 2 possible outcomes because it's about a distance from 0. So the first one is the one that we're more used to, where the absolute value of a number is less than, let's say, 2. Could be 7, could be whatever. But it's where the distance from 0 is less than something, which means it's closer to 0, so we're talking about a nice finite interval like this, from negative 2 to 2 in this case. But you also might have it where the absolute value of a number is greater than 2. So it's going to be the same bounds on the number line. We're saying, oh, well, here's 0, here's negative 2, here's 2. But we're farther away from 0. Our absolute value is greater. So we're going to go all the way here and then all the way here. So in terms of interval notation, this would be negative 2 to 2 very easily. Here on the second one, we are looking at like C, where we're going from negative infinity to negative 2, union 2 to positive infinity. And what you'll notice here is that you're going to end up with these similar patterns. These are the 2 possible absolute value patterns for answers. And you're just going to have to work your way through it and figure out which one's going to make the most sense for the problem. Here we have the absolute value of 2x plus 1 is greater than 9. So since the absolute value is greater than the number, we're going to end up with this type of problem here. So what we're going to do then is we will separate it into a union problem, where 2x plus 1 is greater than 9, and that's this side of the number line. And we also end up with less than negative 2 here. So then in this case, 2x plus 1 is less than negative 9, and that'll be the union of the negative infinity side and the positive infinity side. And we'll solve them separately. Here we add 1 to both sides, so 2x is less than negative 10. So then x is less than negative 5. Notice we didn't flip because when we divided by the 2 is positive, and the negative, we haven't changed the sign, those stay the same. So then we have x is less than negative 5, so that's negative infinity to negative 5. Union, on the other side, we end up with 2x plus 1. When we subtract 1, we get 2x is greater than 8, so x is greater than 4. And on the other side, we end up with 4 to positive infinity. So here we go. Please let me know if you have any questions in the comments or grab a tutoring appointment video on the calendar on Google Classroom. These are the lectures for week 2, so just make sure that you get everything turned in and done by the end of the day on Friday. I'll talk to you later. Have a wonderful day.